Hello. This video is an introduction to a Voxel Global Illumination technology that's now available in the Stride open source game engine. Stride is a C# open source game engine that you might say is somewhat similar in design and concept to Unity, though obviously at its current state in open source it is not anywhere near as comprehensive or capable or bug-free as Unity. But the benefit is it's completely MIT licensed open source, so you can do anything you want with it. You can make anything you want with it. You can use the engine source code in any way you want. So let's talk about VXGI briefly. VXGI stands for Voxel Global Illumination. The specific technique was named by NVidia, who created some research a couple years ago. Now, normally a game handles global illumination by using pre-computation. So let's talk about global illumination. When we light a scene, light that falls directly from a light onto a wall is direct light. But that direct light also then bounces and illuminates neighboring objects. And the way that we normally in the past have computed this is, well, I guess in all cases, is ray tracing, meaning we trace these light rays. And a studio like Unity or Unreal Engine, normally you'll assemble a scene in the engine, in the studio, in the editor, and then you will run a pre-lighting bake, which pre-computes all of those indirect light rays and the ambient occlusion, like the thing that creates this darkness here, and it will pre-compute a light map for the entire scene. And when that's done, your scene is going to be lit nice. It's going to look like this. It'll be very nicely lit. But all of those light maps are frozen. They're pre-computed in an hours-long process. This is much the same process that's used to render animated film movies or special effects, where very long ray trace renders are run to generate this very nice looking lighting. Now, VXGI is a technique that does another approximation of this global illumination in real time. And so this is Unreal Engine with VXGI, where a user is creating a scene and seeing the visualization of global, not just shadows, but global illumination in real time using VXGI. And so this is a pretty interesting technique, and it has limitations. It's not necessarily appropriate for many games because it has consequences like aliasing and flicker as things move, and it takes a big frame rate budget. And so I'm not saying you should run out and think, oh, great, we're going to now make all these games with VXGI. That's probably not going to happen. Big games are going to have to wait for real DXR real-time ray tracing and hardware that can do it faster. But this technology is useful for a number of applications in visualization and simulation, and things where flicker and frame rate and animation motion are not as important. So with that, let's take a very quick peek at what this looks like inside of Zenko. Stride3d. The name of the engine was changed. So here we just have some assets in here. And what we're seeing is a scene that's only lit with a directional light. So here, everywhere the light falls, it's lit up. And if we go to the back side, everywhere the light doesn't directly fall, it's completely black. Now, we could use a pre-computed light baker, or we could put an HDRI map in that would just force light onto everything. But what we're going to do instead is we're going to enable this ambient global illumination, which will cause the VXGI to start to shed light in different areas. So in this case, the glow maps on this ship have now started to cast light around on the floor and on the wall, and the light on that glow and on the floor is now lighting up the front of this spaceman. If we turn that off again, we'll see the front of him with direct lighting is completely black because the light's coming from behind him and there's no direct light falling here. But here, when we have the VXGI on, all of this ambient light that is landed, it's not ambient, but all of this light that is landed here on the floor is now bouncing around on the wall and onto the front of him and providing global illumination of the front of his suit. And you can also see he has quite a bit of this blue tinged color because this ship right here has a lot of blue glow map. And so this is what VXGI is for. And when it's done in real time, it means that all this stuff is completely real time interactive. This isn't a long pre-computed light bake. If we move the spaceship out of the way, then the blue effects are gone. If we take the directional light that's in the scene and we rotate it, we can see interior right here in the house. We can see the amount of light going onto the wall that's not the direct light changes based on how much light is falling in the room. See here, the room's very light because there's light falling in it from the other side. And then here, the room gets darker, and then it gets lighter again. This is real-time global illumination using VXGI. I mean, here's a more dramatic example where there's light falling right here directly. And if I go in and I turn off the ambient, you'll see this is completely black. There is no direct light falling in there. That is all because of VXGI bouncing the light around off the adjacent surfaces and lightening the inside of the house. Now, there are many artifacts of VXGI, so I don't want to sell this as something that solves every single problem in lighting. Aside from performance consequences, the current implementation has quite a bit of light bleed, which is one of the general problems with VXGI. So here you can see this really should not be lit like this. There's a lot of bleed through the back of this surface because the direct light's falling back here and it's bleeding through the edges and on the back. So this is something we're going to be working on and trying to make better. But there is a class of application for which having this type of real-time lighting, either as a visual pre-visualization. I mean, you can use VXGI in this editor just to see what things look like in pre-visualization, either when running your game or when working in the editing studio, and you can still pre-bake your light maps if you want. Now, Stride3d doesn't have a full pre-baked light map solution. It's based on light probes. But there is also VXGI for Unity if you wanted to use VXGI for Unity. And you could use VXGI as a pre-visualization, and then you can still pre-bake your light maps if that's the way you'd prefer to go. But at any rate, this is a new technology and it's interesting. And the next video I'm going to make is going to explain how to get it turned on and set up within Zenko.